Hello, boys and girls of YouTube. Welcome to the lesson. Let's talk today about the basic algebraic identities, and I'll give you an introduction on polynomials. Let's begin. So, let's begin with talking about what an algebraic identity is. As per definition, an algebraic identity is an equation. So, it's an equation, an algebraic equation, which holds true for any values of its variables. So, whatever the values you replace the variables with, the algebraic equation holds true. Let's take a few examples. A plus b the whole square equal to a square plus b square plus 2ab. Now whatever the values you substitute for a and b separately within the equation always holds true. A few other basic examples would be a minus b the whole square equal to a square plus b square minus 2ab, and a squared minus b squared is equal to a plus b into a minus b. Let's talk about proving all of these algebraic identities one by one. Let's pick the first one. Now, the way in which we prove the algebraic identities would be picking one of the sides and finally deriving the other side. So in this example, I choose to pick a plus b the whole squared, so the left side of the equation. This can be written as a plus b into a plus b. Using the distributive law, I expand the equation as a into a into b, plus b into a plus b into b. For details regarding the distributive law, please check my previous video or search on YouTube with the term distributive law on my channel. Let's continue. So a into a plus a into b plus b into a plus b into b. This gives us a squared plus ab plus ba plus b squared. Using the commutative law, we change b into a as ba as ab. For details regarding the commutative law, also look at my previous video in this series. You can search for it on my YouTube channel. Moving on, we add ab plus ab. These are like terms, and we add them as we leave the a squared unchanged, b squared unchanged. This can be written as ab into 1 plus 1. Finally, we get the expression a squared plus 2ab plus b squared. For an explanation about like terms and how to group like terms together, check out my previous video. You can also search for addition, subtraction, multiplication, and division of polynomials of algebraic expressions on my YouTube channel. So we finally get a squared plus 2ab plus b squared. We rearrange the terms to get a squared plus b squared plus 2ab, and so we have derived the right side of the equation. Let's look at proving a minus b the whole squared. Again, we choose the left side of the equation. I can write this again as a minus b into a minus b. Expanding, I write this as a into a, again using the distributive law, minus a into b, minus b into a, and plus b into b. If you have questions regarding how these negative signs come into picture and how the positive signs come into the picture, also look at my previous video. So that is addition, subtraction, division, and multiplication of algebraic expressions. Now, simplifying further, we get a into a is a squared minus ab minus ba plus b squared. Using the commutative law, I get a squared minus ab plus b squared. I add the like terms together, so this can be written as minus 1 plus 1ab plus b squared. This gives us a squared minus 2ab plus b squared. Rearranging the terms, I get the right hand side of the equation. So this algebraic identity is also proved. Let's move on. Let's try to prove this algebraic identity. I choose a slightly different approach here. I choose the right side of the equation and I simplify to get the left side. So that's a plus b, the whole into a minus b. I expand the bracket, so a into a minus a into b plus b into a minus b into b. So this is again by the distributive law, and also the signs are determined by another law which is also described in my previous video. Have a look. A squared minus ab plus ba minus b squared. So this is what it evaluates to. We use the commutative law to convert the ba into the ab. So you have a squared minus ab plus ab minus b squared. Since these are like terms and have a difference in signs, we can cancel these out. These both evaluate to 0. So what we are left with is finally a squared minus b squared. So we reach the left hand side of the equation, and so this algebraic identity is also proved. Let's move on. Let's talk about integers and coefficients. Recall in the first presentation of this series, we talked about real numbers, whole numbers. So an integer is basically all positive and negative whole numbers. This means you have 0, 1, 2, 3, 4, 5, and so on. And also you have minus 1, minus 2, minus 3, minus 4, and so on. So all positive and negative whole numbers is basically the set of all integers. Now let's talk about coefficient. For this, let's take an example of an algebraic expression. So this is 4xy plus 3abc plus 21. The coefficients are basically the real numbers which are in front of the variables. So here 4, 3 and 21 are the coefficients, and the variables would be x, y, a, b and c. 21 doesn't have a variable, but it is a coefficient. Let's move on further. Let's talk about what a monomial, binomial and polynomial is. All three have non-zero integral coefficient and a whole number power. So let's talk about the monomial first. So a monomial is an algebraic expression with a single term, right? So it also has a non-zero integral coefficient and a whole number power. An example would be 4a squared, 5xyz, 9c squared a. So all of these are algebraic expressions with a single term. If you're not sure what terms are, you can refer to my previous video on algebraic expressions and algebraic equations. So the coefficient here in the first monomial is 4, the second one is 5, and third one it's 9. And the powers of the variables are 2, 1, 1, 1 here, 2 here, and 1 here. Note that the powers are not fractions or decimals, so they are whole numbers. So that means it can be 0, 1, 2, 3, 4, and so on. Now, a binomial is an extension of this. It's basically an algebraic expression with two terms. Examples would be a squared plus b squared, xy minus 4abx, and 4cz plus cy. The coefficients here would be 1 and 1. So you have two coefficients. The powers would be 2 and 2 here. In this expression, it's 1, 1. The powers would be 1 and 1. Here also 1, 1 and 1. And the coefficients would be 1 here and minus 4 here. In the third binomial, we have the coefficients of 4 and 1 and the powers of 1, 1 and 1, 1. Now, a polynomial is basically an algebraic expression with more than two terms. So, examples would be a squared plus b squared plus c squared, 3ab plus 3bc plus 3ca. Coefficients in this expression would be 1, 1 and 1, and the powers would be 2, 2 and 2. The coefficients here would be 3, 3 and 3, and the powers would be 1 for all of the variables. Let's talk about a zero polynomial. A polynomial where all of the coefficients are zeros is known as the zero polynomial. An example would be 0x squared plus 0x plus 0, 0abx plus 0by. A zero polynomial always evaluates to 0. Let's talk about a linear polynomial in one variable. So a polynomial with the highest degree of 1 and consisting of a single variable is known as a linear polynomial in one variable. An example would be 3x plus 1, 8y minus 5, 2a minus 3. So these have the highest power as 1. A degree means an expression where the highest power of an expression is known as a degree. So here the highest power of the variable would be 1, 1 and 1. So this is all these three are linear polynomials in one variable. Let's talk about quadratic polynomials in one variable. So a polynomial with the largest degree as 2 and consisting of a single variable is known as a quadratic polynomial in one variable. Examples would be 3x squared plus 4x plus 1, 8y squared minus 5, and 2a squared plus a. So here the degree would be 2, no powers greater than 2 for any of the variables. Here also the same, and here also the same. Finally, we talk about zeros of a polynomial. The zeros of a polynomial are basically value of the variables for which the algebraic expression evaluates to 0. They are also known as roots. So zeros and roots are interchangeable. An example is for 4x minus 8. So 4x minus 8 is the algebraic expression and the root is 2. This means if I replace x with 2, I get a value of 0. So 4 into 2 minus 8. So this gives us 8 minus 8, which is 0. So the root for this expression is 2. Let's see another example. So 3y minus 1. Now the root here is a fraction. It is 1 by 3. If I replace y with 1 by 3, I get 1 minus 1, and that's 0. So the root for this algebraic expression is 1 by 3. Well, that's it regarding this lesson. I would be talking about polynomials, linear polynomials in one variable and quadratic polynomials in one variable in subsequent lessons. I would also be going into detail about zeros of a polynomial in subsequent video. Hope you like the video, and if you like the video, please like, comment and share the video. Please subscribe if you continue if you enjoy my videos and continue to receive updates. Thanks, have a nice day and keep rocking.